We are lifting a leaky bag of sand that has an initial weight of 144 pounds to a height of 18 feet. When the bag reaches 18 feet, it only contains half of the sand. Assume it leaks at a constant rate and the cable is pulled at a constant speed. Weights of the bag and the cable are insignificant. First, draw a sketch and indicate element and how distance is measured. So first we had our origin and we cut individual strips of the bag of sand and where it's going. So that way the origin will follow as it reaches to 18, the height that we're going to. And second, draw a graph that represents the weight of sand, F of y pounds versus the distance from the ground, which is y feet. Find the equation of F of y. So here we've set up a graph, and as you can see, when you first start out, the weight is at 144 pounds, and as the bag lifts to 18, according to the statement, it says it only contains half of the sand when it reaches 18. So since we know that, we can devise F of y and use the slope-intercept form to find the weight of the sandbag. So over here, first we need to find the slope, and since we know that at halfway it only contains half of the sand, which is 144, half of that would be 72. So when we use the slope formula to find the slope, here we get -4, and to find the weight of the sandbag, we plug in our formula, and that would give us this right below, because -4 would be plugged into m, because this would be mx plus b, and the y-intercept is 144, which, to finish off, we would need to set up an integral to calculate the work required to lift the bag to the height of 18. So the integral would go from 0 to 18, and we would set that up to find the integral. To calculate that, it would be simply this. We simply plug in the weight of the sandbag and delta y becomes dy.